Hello and welcome to the selection sort video for UILCS. So what is the selection sort? The selection sort is a sorting algorithm that finds the minimum of the array and swaps it with the first unsorted element. So if I had the array 3, 5, 9, 7, 8, 6, 1, 2, first the sorting algorithm would go and find the smallest value, which would be at 1. And then it swap it with the first unordered value, or first value of the unordered like set kind of, which would be 3. So we're gonna swap 1 and 3. So we have like something like this going on, 1 here, 3 here, and now you can say that 1 is sorted. Okay, 1 is sorted. So we are going to move on. This is going to be the start of our unsorted set, by the way. This is our unsorted set because 1 is sorted. Okay, the next smallest value is 2 over here. So we're gonna read a loop. We obviously like search for that, find it, and then once we found it, we're gonna swap it with the first value in the unsorted section, right? Next, we're gonna do that again. The smallest value is just 3 here. We're gonna swap that with the first value in this unsorted section, which is 9. I don't know why I copied it over, because now you're just gonna have to like go away. Again, we'll repeat this again. So the next smallest value is 5. We can swap that with the 7. So have something like this occur. Then the next smallest value will be the 6. We'll swap that with the first value of the unordered set, which is 8. We'll repeat this again. Copy and paste. Put here. 7 now is our first value of our unordered set. We're going to swap that with 8. Okay, now the smallest value is going to be not 8, sorry. And then we're going to swap that with 9. So swap these around. And then just like with a bubble, we only have one element left that is by default are like sorted. That by default is sorted when we just have one element left. So as you can see, this is selection sort. We basically just go find the smallest value here and swap it with the first unsorted value. Okay, so what would the code of this actually look like? Well, let's just before we even start thinking about the code, let's think of one thing. So these are all gonna be loops, right? This is gonna be a loop to find the minimum. We're gonna do another loop, 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 loop. So you can kind of see that to find the minimum each time we're looping the array, right? And after the array, we'd probably do like a swap. So we're gonna need to hold some value. We're gonna need to know the value for the index of the first unsorted element because that's what we swap with. And then we're going to need to know the index of our minimum value because we also swap with that. So we can also just say that we're going to put all of this in one big loop, right? We're going to have a loop of loops or a nested loop, right? Because we're doing this same loop over and over again. That's nested loop. So we have a nested loop. We can have a variable to hold the index of the first unsorted element and a variable to hold the index of our minimum. So let's get the coding. So here you can see the bubble sort method we implemented last time, bubble sort algorithm. So I'll create a public static void selection. I'm gonna pass in an integer array just like this. Okay, so let's start this off by just defining our two initial for loops. I don't know what's gonna be in these for loops. I don't really have any general idea. I know what the sorting algorithm looks like. I did that, right? Okay, what else do we know? Well, we need it in this for loop is we're going to loop till we find the minimum value. So we want some way of getting the minimum value. Well, typically what you do when you want a minimum value is you check our j, compare it, compare it to some min value that we have set earlier. So let's do that. Let's create a min index and our I. That way it represents our starting position. And then we can just do if r of j is greater than r of min index. Sorry, this should be less than. What we can do here is we can say min index is equal to j. But now we learn there's a problem here, right? If we're starting our j at 0, we're going to be looping through the full array. That means we're going to be looping through all of this, even the sorted components of our array, which is not something we really want to do. We want to only focus, you see which lines are, the unordered elements. So how do we do that? Well, I know that our first unordered element is at I, right? This is I of 1 because we just sorted this, right? And we have it at 5, right? Here, sorry, something like this might make more sense. And we had our initial loop before everything got sorted. And let's just say it looks something like this because I didn't save the initial position. Right, so this would be I of 0. But then, and as you can see, I of 0, everything is unordered, is our first iteration, right? So I of 0 represents our first unordered element. But then here at I of 1, well, we have our 0th position sorted. We just sorted that, right? So then it makes sense that this represents our first unordered element. And which index is that? It's 1. Let's say we're in I of 2. Which index is this? It's 2, 0, 1, 2. So you can kind of see how our I variable actually keeps track of the first unordered element for us. So the code, well, first of all, we don't want it to be this. We don't want this just to be I, because what does that mean? That means we're going to be comparing R of I to R of I. It's just, I don't think it'll hurt our code too much, but it's an unnecessary comparison. You don't need that. And then lastly here, now we get to do the swapping of the first unordered element and our minimum. Well, we said that was just I, right? So I can say R min index is equal to R of I is equal to R min index. But wait a minute, see, an error issue here actually arises with the fact that we are reassigning R min index to R of I and then trying to assign that new value to R of I, right? But this already contains this value. So we actually need to do is create a temp variable to store our old R min index, and then we can assign that here. Okay, so let's run selection sort. I have our array pre-put in, and yeah, you see it sorts. So that is selection sort, and there's one last thing we need to cover, which of course is the time/space complexity. So, well, let's think about what's our best case for time complexity for this. It's going to be O of n squared. Our average case is going to be O of n, and then or O of n squared, and our worst case is also going to be O of n squared. And it makes sense why it's all O of n squared because it's just a nested for loop, right? So you're going to a for loop loops through every element n times. A nested for loop is going to run that inner for loop n times, so you're going to do n squared or n times n. Okay. For space complexity, our best is going to be O of 1. Our average is going to be O of 1. And finally, our worst is also going to be O of 1 because in the selection sort, we are not creating anything new. There's no new stack, anything for the stack in here. No new stack traces or any such things. I'm not too good with space complexity. I will be when I make my video on it. This is a little bit of a precursor to that. But essentially here, all we're doing is editing just one for one array, right? We're not calling any functions again. We're not doing anything that might add more elements or add to our stack. The space complexity won't really increase, or it'll be constant. All right. So that is selection sort in Java.